Okay, we're back, still studying convex lenses. We're going to work a sample problem. I'll remind you, however, of what we saw last time. We have a convex lens. There's the axis. There's an object on this side of the lens, labeled O. Not shown on the right side of the lens is the observer's eye. The image is shown here. The distance between the object and the lens is called the object distance, labeled x, always a positive number. The focal length is the distance between the focal point and the lens, always a positive number. Y is the so-called object distance, the distance between the, I meant to say it's the so-called image distance. It's the distance between the image and the lens. Unlike x and f, which are always positive, y can be positive or negative. In this case, it's positive, and never mind y for now. But the rule is this: if the image is on the I side, then y is positive. So y is positive if the image is on the I side. And by the way, there are some important correspondences that I'd like to point out to you. I won't prove it just now. But if y is positive, then the image is on the I side. And by the way, if the image is on the I side, as was the case in the previous part where we had a ray diagram showing the location and orientation of an image, if the image is on the I side, then the image is real as opposed to being not real. There's another word that stands in place of not real that I'll mention when the time is right: virtual. And so we have the following: if the image is real, the value of the image distance is positive, and the image is on the I side. If any one of these statements is true, the other two are automatically true. If any one is false, the other two are false. So for example, if through our lens equations, it turns out that y is a negative number, y is not greater than 0, then this statement would be false, and that the object would not be on the I side, it would be on the object side, on the side of the lens where the object is. And by the way, the image would not be real. So again, if any one of us is true, they're all true. If any one is false, they're all false. Now let's work a sample problem. A lens, convex lens, has a focal length of 12 centimeters, and we wish to determine where an object would have to be placed on the other side of the lens in order that it be 3 times taller than the object and upside down. The negative sign means upside down. Well, from the magnification equation shown here, we set this ratio equal to -3. That tells us that y equals 3 times x. So let's substitute this expression for y in the reciprocals equation. We do that here. 1 over x plus 1 over 3x equals 1 over f, which is 12. And I make both fractions have the same denominator, shown here. And so we have 4 over 3x equals 1 over 12. Final answer is that if we place our object 16 centimeters from the lens, the image that's formed will be 3 times taller, and it will furthermore, because of the negative sign, be inverted. And while we're at it, let's put to use these correspondences. We see here that y equals 3 times x, but x is always positive, so y in this example is positive. But if y is positive, then this is true, which means the other things are true, which means that were we to do a ray diagram as we did in the previous part, we would find that the image is on the side of the lens where the eye is. And furthermore, we could claim that there really is light coming from that place in space where the image is. In other words, the image is real. We'll have more to say about convex lenses next time.